Hello, I am Brad Washburn, and this is my element project on xenon. Now, xenon is a noble gas. Its element symbol is Xe, its atomic number is 54, and its atomic mass is 131.293 AMU. So a little bit on the backstory of xenon, the history of it. Xenon was discovered by Scottish chemist Sir William Ramsay and English chemist Maurice Travers on July 12, 1898. Prior to the discovery of xenon, the chemists had found neon, argon, and krypton from liquefied air after conducting studies on liquefied air in search of new elements. After repeatedly distilling gas in a liquid air machine in order to extract more krypton, the chemists found a heavier gas that gave off a blue glow when tested in a vacuum. This new element was, of course, xenon, and it was classified as part of the inert gas group of gas elements, or a noble gas. So now, what are some physical properties of xenon? Well, xenon is a heavy gas. It has a density of 0.005366 grams per centimeter cubed. Furthering on this, xenon has a boiling point of negative 108.099 degrees Celsius and a melting point of negative 111.75 degrees Celsius. Xenon is colorless when non-excited, and it is odorless. And then given the melting and boiling points, xenon is gas at STP. So now moving on to some chemical properties of xenon. Xenon has a first ionization energy of 1,170.36 kilojoules per mole. Xenon also has an electronegativity value of 2.6 using the Pauling scale. You might be thinking, why does xenon have an electronegativity value if it's a noble gas? Well, although it is a noble gas and highly unreactive, xenon can form compounds, and therefore it has an electronegativity value. And we'll talk a little bit more about this later. And then lastly, the electron configuration for xenon, the shorthand is krypton in the brackets, and then 5s2, 4d10, 5p6. So now, as we talked about earlier, xenon can form compounds. The first compound that we'll talk about is xenon hexafluoroplatinate. Its formula is xenon, platinum, and fluorine. Depending on the revised and initial, there's kind of two different ways to think about it, but they're both depicted on the slides. The compound was discovered in 1962 by chemist Neil Bartlett, and it's very important because it was the first noble gas compound ever created. It really pioneered research into noble gases and reshaped how they were thought of now that they were proved to be able to form compounds, even though they are noble gases. So, furthering on this idea is the compound Tetrazino gold, and its formula is AuXe4. It is a compound between the noble gas xenon and the noble metal gold, and it is the first compound of that nature. And it's kind of in that same vein of, it might not be super useful, but it is useful in the sense that it pioneered research and furthered research on noble gases. The next compound is Xenon Difluoride, and its formula is XeF2, and it is a compound primarily used as an anti-tumor agent. And the last compound is Xenon Monochloride, and its formula is XeCl. This compound is used in combination with other noble gas compounds and XMR lasers, which are used in eye surgery. And then in the top right, you'll see the depiction of xenon difluoride. And then in the bottom right, you see xenon monochloride and its use as in XMR lasers. Now, furthering this idea of how xenon is used in our everyday life, well, we see it everywhere. Xenon is used in car lights, camera flashes, and tanning beds because of its blue glow. Xenon ions are also used to propel spaceships and satellites in orbit, and it's used in ion propulsion engines. Xenon can also be used in medical imagery, like xenon CT scans, which we'll show later. And then it can be used medically in eye repair surgery and as an anti-tumor agent. So what are some fun facts about xenon? Well, Xenon has a natural abundance of 0.086 parts per million by volume, making it a rare element. Xenon is also extracted commercially through liquefied air, the same process used to discover it, which is kind of cool. The name xenon derives from the Greek word xenos, which translates to the stranger. And lastly, xenon formed the first noble gas compound, which we talked about earlier, and it was really cool to research how it really pioneered noble gas research. Now, here are some images about how xenon is used in everyday life. We see the XMR lasers in the top left, which are used in eye surgery. In the bottom middle, we see a xenon CT scan being used in medical imagery. And then the top right, we see xenon car lights, which are the bright lights that you see when compared to the halogen lights. So it's pretty cool. It can be used in a wide variety of ways. And then, why is xenon important to the world? That's really the question. Well, for one, it pioneered noble gas research by creating the first noble gas compound. It is used in a plethora of life-saving medical devices, from CT scans to XMR lasers. It's really vital to a lot of medical technologies. And then building off of this, it's used in a myriad of other technological advancements, from car lights to rocket propulsion. And then, as technology advances, xenon is only becoming more useful. If we think back 50 years, we didn't have this technology. Xenon wasn't as useful. But as technology is advancing, the use of xenon is as well. And I think that's really cool to see how xenon will be utilized in the future. And that's really it for the Element project. Here are my sources. I hope you enjoyed, and I hope you learned something about the element xenon. It's a noble gas, but it is a very interesting noble gas. Thank you.